and get you to actually step into the lab. What we do in the lab is actually measure directly, in a quantitative fashion, what is the impact of video games on the brain. And so I'm going to take a few examples from our work. One first saying that I'm sure you all have heard is the fact that too much screen time makes your eyesight worse. That's a statement about vision. There may be vision scientists among you. We actually know how to test that statement. We can step into the lab and measure how good your vision is. Well, guess what? People that don't play a lot of action games, that don't actually spend a lot of time in front of screens, have normal, or what we call corrected to normal vision. That's okay. The issue is what happens with these guys that actually indulge into playing video games like 5 hours per week, 10 hours per week, 15 hours per week. By that statement, their vision should be really bad, right? Guess what? Their vision is really, really good. It's better than those that don't play. And it's better in two different ways. The first way is that they're actually able to resolve small detail in the context of clutter. Though that means being able to read the fine print on prescription rather than using magnifier glasses, you can actually do it with just your eyesight. The other way that they are better is actually being able to resolve different levels of gray. Imagine you're driving in the fog. That makes a difference between seeing the car in front of you and avoiding the accident or getting into an accident. So we're actually leveraging that work to develop games for patients with low vision and to have an impact on retraining their brain to see better. Clearly, when it comes to action video games, screen time doesn't make your eyesight worse. Another saying that I'm sure you have all heard around: video games lead to attention problem and greater distractibility. Okay, we know how to measure attention in the lab. I'm actually going to give you an example of how we do so. I'm going to ask you to participate, so you're going to have to actually play the game with me. I'm going to show you colored words. I want you to shout out the color of the ink, right? So this is the first example. Orange, good. Green, red, yellow, red, yellow. You got my point, right? You're getting better, but it's hard. Why is it hard? Because I introduced a conflict between the word itself and its color. How good your attention is determines actually how fast you resolve that conflict. So the young guys here at the top of their game probably legged it a little better than some of us that are older. What we can show is that when you do this kind of task with people that play a lot of action games, they actually resolve the conflict faster. So clearly, playing those action games doesn't lead to attentional problems. Actually, those action video game players have many other advantages in terms of attention. And one aspect of attention which is also improved for the better is our ability to track objects around in the world. This is something we use all the time. When you're driving, you're keeping track of the cars around you. You're also keeping track of the pedestrian, the running dog, and that's how you can actually be safe driving, right? In the lab, we get people to come to the lab, sit in front of a computer screen, and we give them the little task that I'm going to get you to do again. You're going to see yellow happy faces and a few sad blue faces. These are children in the schoolyard in Geneva during recess, during the winter. Most kids are happy. It's actually recess. But a few kids are sad and blue because they've forgotten their coat. Everybody begins to move around, and your task is to keep track of who had a coat at the beginning and who didn't. So I'm just going to show you an example where there is only one sad kid. It's easy because you can actually track it with your eyes. You can track, and then when it stops and there's a question mark and I ask you, did this kid have a coat or not? Was it yellow initially or blue? I hear a few yellow, good, so most of you have a brain. I'm now going to ask you to do the task, but now with a little more challenging task. There are going to be 3 of them that are blue. Don't move your eyes. Please don't move your eyes. Keep your eyes fixated and expand, pull your attention. That's the only way you can actually do it. If you move your eyes, you're doomed. Yellow or blue? Good. So your typical, normal young adult can have a span of about 3 or 4 objects of attention. That's what we just did. Your action video game player has a span of about 6 to 7 objects of attention, which is what is shown in this video here. That's for you guys, action video game player.